Hola. Today we're going to talk about combining functions. So we're going to hop right to it. So you guys can see this notation here, given that we have f of x and g of x. This notation right here, it says f plus g of x. Don't confuse that as being like f plus g times x. That's like not something that we're going to confuse. Okay, we're going to sound more intelligent than that. That's f plus g of x. This is f minus g of x. This is f times g of x, right? So it's taking these two functions and performing these operations. In other words, we're combining them. Something that you just want to keep in mind with this is that when we do combine functions, it could really affect the domain. Mostly you'll see that it'll be really obvious when we have division of two functions. Something to keep in mind. So what better way than to start with an example? We have f of x equals 3x squared plus 2, and g of x is 2x plus 5. So what I'd like you to do is I'd like you to combine them and state the domain. So go ahead and take a minute, put me on pause, actually do that. Don't just copy what I'm writing because you're not going to grow or learn from that. And then after you do combine them, don't forget to state the domain. Really think about it. Okay? Pause. Okay, so let's start with f plus g. So I added the two functions together. I got 3x squared plus 2x plus 7, and that domain is all real numbers. Very similar for f of x minus g of x. Subtracted the 2. Make sure you subtract 2x and you subtract a 5 there if you did get a different number for your constant. Same domain. This next one I want to multiply f of x times g of x. So notice, why does it do that? I didn't do that, just so you know. I need to multiply here, so once I do, I get a cubic. This has a domain of all real numbers as well. Now this last one, f divided by g, you'll notice something a little bit different here. We get 3x squared plus 2 divided by 2x plus 5. Now, this doesn't have a domain of all real numbers. Because think about what would happen if I plugged in negative 5 halves for x. What would happen? Well, it would become undefined. So my domain is pretty much everything except for negative 5 halves. So if you go to the top of the next page, you'll notice that I ask you a question, or I ask you to do something. I ask you to explain why the domain is different for this last example. So go ahead, put me on pause and write that down. Okay, so another example here. We have a new f of x and a new g of x, and I'd like you to find the domain of dividing f divided by g and then dividing g divided by f. Curious to see how they could differ. So go ahead, put me on pause and do that. Okay, so notice that I started with both by just finding out what those functions would look like when I combine them with division. So I have the square root of x minus 5 up top here, and then I have it in the denominator here. Now, my domain, think about the x values I could have. Now, if your initial instinct was to look at the denominator, so negative 4, everything besides negative 4, well, also keep in mind that this square root symbol does also restrict the domain. Because think about if I plugged in, let's say, negative 10. Negative 10 minus 5, square root of negative 15, that can't happen. So my domain here is bracket 5 to infinity. Think about why I would have a bracket there. For the second example, now this time that square root symbol is in the denominator, so I have 5 to infinity. And notice that this one is a parentheses. Really think about why couldn't it be a bracket like it was in the one above. So conclusion here, we talked about how to combine functions by adding, subtracting, multiplying, and dividing.